So imagine you have your own data center, you're the CEO of a data center, you're responsible for it, and you have some demands. You want to improve your asset utilization. Yes, some outages quite frequent, quite lately, so you want to decrease the risk of a new outage. You want to manage your CAPEX and your OPEX. You want to improve your performance, reduce your costs, and you want to have more information about your energy balance because you have to report to it and you want to comply with new standards. And your conclusion is, okay, we need a DCM solution to help us to reach that goal. Okay, so that data center got a visit from the local administration. So this is the data center. It's using, as you can see, 4.1 megawatts. So this is a so-called big data center. So they need to have a certified EPMS system. And the local administration said to the CEO, oh, listen, very good. Your current PUE is 1.46. And you know, if you look to your permit, your maximum allowable PUE is 1.3. So your current PUE is way too high. Now you have 12 months to bring your PUE below 1.3 because this is not acceptable. You're exceeding your permit limits. So the next step is the CEO went to the operation manager. He said, well, I had a visit from a local administration. Our PUE is too high and it should become below 1.3 coming month. So the operation manager responded to the CEO, well, that's very nice, but if I look to my EMS, my best part of my PUE is 1.3, my worst part is 1.6. And what I already did, I did cold eye containment. The vendor of the cracks and the air handling units and the chiller came by, they optimized their equipment. So I think I did everything I could. And to be honest, if you look to the design PUE of our data center, it's 1.25. But the reason that it's so high is not because of me, because I did everything I could, it's because of sales. I see that room 2 is hardly filled and sales should sell more. And if the room 2 is also filled, then we are within the range. So go to sales, there's nothing I can do. And actually this is quite a normal situation because in general, an operation manager has mainly his PUE to manage and control and optimize his data center. So he has no more ideas how to improve anymore. What you need is an integrated DCIM system, like the one we are using based on Ignition. If you go to the top right part, you see the white space. In the white space, you see the recs and the temperatures and the humidities and the cracks. So you have a good idea about your SLA contracts and so on. The left part is your EPMS, so the electrical power monitoring system. You can see your power consumption. The bottom part is your BMS, so you know everything about oil users, diesel users, water users, and so on. And the right bottom part is the CMS, the cooling management system. So now if I change on the CMS part the water temperature of a chiller, you can straight away see what it will do on your energy consumption. And you also see straight away what it does on your white space. So you have a good idea if you change something, what the final result will be, both on efficiency and both on white space. If you have an integrated system, you can do much more with it. Okay, one thing you can do, you can put all that information in a balanced scorecard. So this is a balanced scorecard, again, built in Ignition. In the middle, there's a composite performance index. But if you zoom in to this balanced scorecard, which I will do step for step, it starts with the PUE. You can see that my PUE is 1.46 as showing in my previous story. And you can see the two parts, 1.25 and 1.62 for the two rooms. And so together it will follow the PUEs. And if you do the math again, like I did in the previous slide, you can see 4.1 megawatt power consumption, 2.8 megawatt to IT. So that will result in a PUE of 1.46, and it should be below 1.3. Now we're looking at the EER. The EER, the energy efficiency ratio, tells me something about my cooling efficiency. It says 6.2. And if you want to calculate the EER, it's IT power divided by the power needed for cooling. And you can see in room 1, I have an EER of 8, and in room 2, I have an EER of 1.6. But I'm using a DIX cooler and a direct expansion cooler. And the vendor told me that an EER of 7.5 between is feasible, and everything is perfect. It can even go up to 9. So I know in this case, my EER is too low. And I also see in section 2, room 2, that my EER is 1.6, which is extremely bad. So I know at least something is wrong in room 2. Okay, and looking to my part of my UPS capacity, I see two things. I see that my total load is around 30%, 31%. So that's quite low. And UPS is never efficient when it is so low. And the other thing I see is that there is an imbalance. So between the phase 1, 2, and 3, there are differences, and differences in phase balance in phases will result in zero currents, and zero current is 100% lost. So two things are wrong: balance and currents. And load. And if I look to the total UPS part, including my cabling, my UPS efficiency is at 87%, which is not very good, I think. The cooling part, again, this really scares me, because what's happening? I have two rooms, section 1 and section 2. And I know in each room I have 5 crack units. So room 1 has 5 crack units and room 2 has 5 crack units. And I see that my load in room 1 is 83%. So I know I've lost my redundancy over there. So that's a big issue, because that does lead to an SLA violation. If I look at my temperature, my humidity, and my rate of change of temperature are still okay, but I've lost my N+1 situation, which is quite worrying, because if one crack unit now will fail, then I will have an outage on that room, and that's something I really want to prevent. What I did, I went to my customers and the customer from room 1, and I found some very nice customers, and they permitted me to move from IT from section 1, from room 1 to room 2. So that's the step I'm going to take. I'm going to move a part of my IT equipment from room 1 to room 2. Now something interesting has happened, as you can see. My 83% in my section 2 is now lowered to 61%. So I have restored my N+1 again. And the second interesting part is, if you look to a crack unit in general, it's most efficient when it runs around 60% load. If you go lower, it's less efficient, and if you go higher, it's less efficient. So it's a double win. As late compliancy, my N+1 is back, so my redundancy is back again, and it will also straight away have an influence on my EER. So now my section 2 has increased, as you might remember, it was 1.6 to 8.2. So instead of having a total EER of 6.2, I now have an EER of 8.3, which is above the targeted of 7.5, which my vendor said was the minimum I could reach with my EER. So I have a much more better situation right now. And the other thing is, that's also quite interesting, my POE has lowered from 1.46 to 1.3, just by moving some IT equipment, and that was what this dashboard was already showing me. So I'm almost right, almost below or equal to 1.3. So what else? The other step I'm going to take is decreasing my UPS capacity and my load balancing. Normally, you use this kind of dashboard not to decrease capacity of your UPS, but you use normally modular UPSs, and you're going to make sure that your UPS size equals the load you have. And in this example, we're using a modular UPS, and so we're going to detach some modules. So then in that case, we're going to decrease the UPS capacity. So we just switch down some of those modules, do not use the batteries anymore. And the second step we're going to take is load balance. And normally, if this is a load chart coming from Energy Star UPSs, of course, the form of the trend will be more or less the same. The numbers will vary on type and size and manufacturer. And in these two, you can see if a UPS has a 30% load, it has an 87% efficiency. And if you go to an 80% load, you can say you will run up to 93. So you can see this is a normal trend, and normally when you come above 80, it will decrease a little bit again. So you know your most efficient part will be around 80% load. So detaching a part of the UPS capacity will help you to improve your performance. And the next step is load balancing. So the way we are showing it, the darker blue lines are the actual loads, and you can see an imbalance, and the green one are the failovers. and then that's your redundancy. So in this case, it's not balanced and you have lost your failover redundancy. That's wrong. So, and by balancing, you will save a lot of money, because then the zero currents will disappear, and that will means actually, theoretically, your cable lengths will be cut in half. So your losses will be gone in this situation. So that's the next step, load balancing. So make sure that every feed has the same load. So not those big steps anymore. So that's what I did. Detached from a modular UPS segment, we balanced the load. And what's interesting right now is that our efficiency went up from 87 to 94%. So we also gained quite some on the UPS part, and now our POE is below 1.3, it's even 1.25. And do you remember in the beginning that the operation manager said, well, I did everything I could and there is nothing I can do? Well, actually he was right, because he had no idea. He didn't have the tools. But if you have an integrated DCIM system and you put everything in this case, a better scorecard, you have so much more knowledge and tools to help you. And there are many other tools, by the way. There are many other tools you can use to optimize your data center. And I think the balance scorecard is a big step forward, because it gives you so much more information as just using the POE, which normally a data center does at the moment. Okay, I also told you, what does it bring? So show me the money. So this is a little bit bigger data center. So it's a co-location site from 12,000 square meters. They're using a 15 megawatt hour. So it's 3 times as big as the example. And the energy purchase price is $10 per kilowatt. And if you have a POE of 1.46, your yearly energy consumption will be $13.1 million US. If you take the step we just showed you, and the POE is lowered from 1.46 to 1.25, your energy consumption is lowered from 15 till 12.8 megawatts. So your new energy cost will be $11.2 million US. That means you will be saving $1.8 million yearly by just taking some simple steps. In this case, a DCIM system will have an ROI of a couple of months, 3, 4, 5, 6 months, and you comply with your local legislation. So it's very, very worth the money to buy a DCIM, but really use it as where it is meant to be for.